times pi over 180. Check the kind of answer they want you to get. Find the area approximately. Do not round until the final answer, then round to the nearest tenth. In other words, they want you to multiply out pi. They don't want the exact answer. So you multiply everything out to the nearest tenth, which means to the nearest 1 decimal point. Okay, and then simplify this and get your correct answer. Simplify and get the correct answer. All right, so remember, I just want to make sure you remember that if you are given angle in degrees, when you are told to find the area of a sector, you change it to radian. If you work with degree, your answer will be wrong. I hope that is understood. All right, change your answer, your degree to radian, then work on it. Okay. Well, let's see what this question is saying. I already have taken 3 questions that I needed, just 3 things I need to work on. All right. One and when we finish working on this, and if I have people still have problems with it, I might actually take it out, because some people had problems with it last year. And okay. A 198 megawatt solar power plant requires 627,000 square meters of land to collect the required amount of energy, and so on. Okay. Okay. If this land area is circular, be careful. So they're trying to ask you a unit circle question using, so this land is circular. So let's draw this circle. All right. And one thing you want to know is that square meter. So that is the area of that circle. Area of a circle is pi r squared. Pi r squared. And pi r squared, which is that area, is equal to 627 square meters. So they give you the area. If this land area is approximately, if this land area is, approximate its radius. That's an easy question. They ask you, maybe somebody start going to. So I told people last year, it doesn't really matter what I say, big one. All you have to do is solve for R, solve for radius, approximate the radius, solve for the radius. That's it. So divide both sides by pi, and I have divide by pi. Okay, and then the next thing you want to do is the square both sides. Find the square root of both sides. R is equal to plus or minus square root of the quantity. I'm just going to arrow this quantity. The quantity there. I put plus or minus. One thing you want to know is that the radius is never going to be negative. Radius, if you find your radius to be negative, that is something wrong. So be careful that your radius is not going to be negative. Okay. All right. So the radius, your answer should be positive. And then get your calculator. So I'm going to get my calculator right now. I put that quantity on the right-hand side in my calculator. So I will start 627,000. All right, divided by pi. Everybody knows where pi is. But suppose you don't know where pi is, let's look for pi. We're going to look for pi. Pi is right here, second pi, right here, divided by pi. So don't forget, pi is there. If you cannot find pi, go to catalog and find it. When I get this answer, I'll find the square root of it. I'll get the positive square root of that answer. Second square root. Square root. Where is my square root? Right here. and then I put the answer there, second answer. The answer is this. And I'm told to leave my answer to the nearest tenth. So I hit enter. My answer to the nearest tenth is 447.7 meters. Therefore, the radius of that circular land is 446.7 meters, because I'm told to leave my answer in meters. And by the way, I'm looking for the radius, I'm not looking for area. So area is square meters, but radius is that. So this is not bad, because some people complaining last year that question was difficult. It's not difficult. All right, so I don't see any other question in that practice test that is going to be. Okay, let's go back. Let's keep on walking. All right, let's go and start going back to the ones we did the other day. Before we continue, I want to show you the, I'm going to give it to you, but I'll show you right now. Trig identities. All right, so we talked about trig identities a lot. So I just want to make sure that we go back and look at it today. I pulled my formula sheet. I'll put this formula sheet in, actually it needs to be in all the folders. All right, so let's start from at the beginning. I wrote Socatua. This formula sheet will not let me write on it, so it wouldn't let me write on it, but I'm going to really show you that everything we talked about. So Pythagorean identities, so we are going to mention it again. Socatua, it's the 6 trig ratios. And somebody asked me, where is the Socatua? It's not in the textbook. I said it yesterday. Some of the things I'm going to say will not be in your textbook, but I have taught this class for a long time, but I know that the most important thing you need to know in 6 trig ratios is Socatua. Okay, and the reciprocal identities. We already said that sine theta and cosecant theta are reciprocals of each other. If I know cosecant, I know sine. Can you see this? Somebody, can you see the formula sheet?
Yeah.
Okay, good. Okay. See, all these are the reciprocal identities: cosine to secant, tangent to cotangent, cosecant to sine, secant to cosine, and so on, cotangent to tan. So you don't have, and then these are, I don't even know. I don't want to say spoon feeding again, but anyway, we are going to give you formula sheets. So I'll put this. You can use it to take your test that way. I don't see how you cannot make 100. I don't really see how you cannot make 100. Quotient identity. Well, we talked about it the other day. The tangent of theta is sine over cosine. We are going to prove it again today. Cotangent of theta is the reciprocal of tangent. Therefore, since tangent is sine over cosine, cotangent is cosine over sine. All right, so we have seen this, but we're going to make sure we know it, because we need it with for sum and difference formula next unit 2. Negative angle identities is there. We actually need to talk about it in unit 2, because we don't need negative angle now. We don't need this one now. We don't need this now. But I want you to know that cofunction, that is comfort. You will see cofunction in this test, but it doesn't really matter, because cofunction identity, the most important thing is that sine and cosine are cofunction identities. What does this mean? If I know that cosine of 60 is 1/2, then sine of 30 is 1/2, because they are cofunction identities. So 90 minus 60 is 30. So cosine of 60 is 1/2, and the complement of 60 is 30. Sine of 30 is 1/2. That's what I'm talking about. So sine and cosine are cofunctions of each other. Just say sine and cosine. Tangent and cotangent are cofunctions of each other. In other words, if I find sine 30, 90 minus 1, then cosine of 60 will be almost the same thing. We can check that later on. So cotangent and tangent and co-functions are co-functions. Cosecant and secant are co-functions of each other. So if I can find cosecant of 80, then secant of 10 is going to be the same. Okay. We need all these other product rule, double angle formula. We don't leave, some things are here, but this is not in this class. Limits are in calculus 1. So we're not going to be doing limits, trust me. Sum to products in this class, sum and differences for next unit 2. So we really and then we need, maybe I will write it later on. We need Heron's formula to find the area of a triangle. All right. We can also use matrices to find the area of a triangle. You might be told, we shall see that in cosine and sine rule. I think it's unit 3. But anyway, so I have shown you this, which this formula sheet. So I don't want it to be short of any formula. And so you know that that test is going to be an easy test, just like introduce yourself is an easy test. But if you choose to make a 0 there, then I can't stop you because somebody chose to not do well there. But remember to tell me if something came up, you couldn't do that discussion. If I didn't hear from you, you keep your 0. And if you made less than 100, it probably means you did not respond to more than two people's thread. You are told to respond to 2 people's thread. Okay. All right. We did this last class. Let's talk about this. Remember that a positive angle goes from x-axis in counterclockwise direction. We hammered on it last class. All right. And so right now, I am given an angle in the second quadrant, and I'm told to find the 6 trig ratios. Actually, this one looks like the one we just did the other day. But the only reason why I came here is because I emphasize all students take calculus. I want to emphasize that. I also want to emphasize that in quadrant 1, you have sign x and y are positive. In quadrant 2, x is negative, y is positive. In quadrant 3, x is negative, y is negative. In quadrant 4, x is positive, y is negative. Also, in this, I'm just going to put all these things here. The reference angle phi, I called it phi last class, but you can decide to call it anything you want to call it. If you want to call it beta, that's fine. Call it alpha, call it theta, whatever. But you know, theta is the angle in standard position. So I don't want to use theta. So what if I decide to call it beta today? Yes. If I decide to call it beta today, then the reference angle beta is equal to the same as theta in the first quadrant. We said that last class, and it's in the PowerPoint. In the second quadrant, the reference angle, which means the angle which you're going to use to find others, which should be an acute angle, is theta. Of course, 180 minus theta. 180 minus theta. So 180 degrees, 180 degrees, or pi minus theta. Therefore, if I'm told to find the reference angle of 150 degrees, then 180 minus 150 is 30. Therefore, the reference angle is 30. That's it. And we're going to be solving problems now. Okay. So in the third quadrant, reference angle, beta, if you want to call it beta, is the angle theta, which is in the third quadrant, which is greater than 180, because it's greater than 180, minus 180. Theta in degrees minus 180 degrees. So suppose I'm talking about angle 210. 210 minus 180 is 30. Therefore, the reference angle is 30. Okay, let's come over here. In the fourth quadrant, beta, the reference angle is 360, and 360 is 2 pi. But I'm going to write 360 here. 360 degrees minus theta. Well, this is a review of what we said the other day, but it's very important that you know. You really need to know how to do. There are so many things you really need to know how to do this. How to do this. Okay, I need to move up a little bit so I can find it. Okay, and then we will be solving a problem. And by the way, in this question, we are told to find 6 trig ratios here. The 6 trig ratios, you want to draw a triangle, or whichever way you want to do it. There are so many other ways you can do it. I want to do it in one way because there are other ways. In fact, when you watch Khan Academy, YouTube, you read your textbook, anywhere you go, you will see that so many people develop so many different way of doing it. So, but if you understand somebody's method, that's fine with me. You don't have to like what I'm doing. If you like it the other way, that's good to me, provided you get it. So of course, you know that this is -3, and it's for the direction, is not for the triangle, and this is 4. I like to bring this triangle out, and I'm not going to put negative. I just want to make sure that nobody thinks that a right triangle is negative. Okay, so this is 3, this is 4. I know that only sine and cosecant are negative in the second quadrant, so I'm not worried about remembering. But I will find this by Pythagorean theorem. 3 squared plus 4 squared is equal to hypotenuse squared. Let's call it x. So x squared. By Pythagorean theorem, this is 9 plus 16. We already did this several times the other day. And so this is 25, which means that x equal to 5. Now let's not. So it's a Pythagorean triple. We talked about this a lot of time. So the important thing now is that we don't know this angle. Whatever this angle is, that's not what they're asking us. I don't know this reference angle. Everybody look. I don't know what this reference angle is. But it doesn't really matter if I know what it is or not, because they're not asking me the angle right now. Find the values of the 6 trig ratios. They're asking me about ratios. Ratios. That's what I'm interested in. They did not say find the angle. Okay, so let me go from what I just found. Sine theta is opposite to phi. You can call this theta, whatever you call it, that's fine. But opposite over, remember SOHCAHTOA. SOHCAHTOA. So sine phi or theta is opposite over hypotenuse over 5. And since I know sine and I know cosecant, means cosecant, yes. All right, so then I'll go to wherever cosecant is and write it there. Since sine is 5 over 4, cosecant is hypotenuse over adjacent. And then I'm going to go back a little bit and find cosine, and cosine is adjacent over hypotenuse. So 3 adjacent to theta over hypotenuse. Then I'll go back to wherever the reciprocal of cosine is, which is secant, and I go back, I write hypotenuse over adjacent. And then, so it's not a big deal. So I will be surprised if you don't all make, I give you opportunity to make A's in my class. Trust me. Sometimes I have 18 out of 20 A's. But really, some people don't, if you don't put in all the efforts and you don't make A's, so it's not my fault then. I give people opportunities to make A's in my class. And if you take that opportunity, you can make A's in all the tests. Okay, so the tangent of theta is opposite over adjacent, and the cotangent is adjacent of opposite. That's all. That's all. That's all you're asked to do. You can find this. Okay, let's go to the table. Let me tell you something again. Somebody felt. I'm not surprised. I'm not going to be worried if somebody doesn't know how to rationalize the denominator. But you bet, you know it, okay? So rationalize the denominator because you're not allowed to leave a radical in the denominator. Okay, so all you have to do is 1 over root 10 multiplied by root 10 multiplied by root 10. You haven't actually done anything because you multiply by 1 over 1. Anyway, so you now have root 10 over 10. That is your answer. Something here, you can do that. I don't want to do questions like this for you. I put all this in so that people will see questions they will answer. Okay, let's read this question very well. Sketch an angle theta in standard position, be careful, such that theta has the least possible positive measure. And the point is -6, -8. They have negative, negative. So you already know that they are this is the third quadrant. In the quadrant, X is negative, Y is negative. So that's not a big deal. But you want to show this is the angle in the third quadrant. They give you negative, negative. Therefore, that angle has, so it says, has the least positive okay, measure. And so the least positive measure, say if you find this angle, you are going to have or suppose you found the coterminal angle coterminal to this. Did I say they might ask you to find the angle coterminal to this with the least positive measure. Then you want to just make sure that revolution can be multiples of 1 revolution, 2 revolution, how many revolutions? And then you can actually start looking for, by the way, in this, I'm going to bring it out. So let me bring that angle out. In other words, that is so this side is 6, this side is 6. By the way, we forgot something. I think I didn't forget, but there are two triangles that are called special right triangles. I drew one the other day. So 30, 60, 90 was the one we did, but let me make sure we 30, 60, 90. So remember we already worked on 30, 60, 90, where the opposite side to 60 is root 3, and this is 2, and opposite to 30 is 1. Don't forget that. Okay, the other one is let me actually go to my whiteboard because I need a whiteboard to make sure you understand this. So the 45, 45, 90 is what I want to talk about now. And so we can solve that problem. We need 45, 45, 90 to solve this problem. All right, so I need 45, 45, 90. Okay. Remember when you were in geometry, high school geometry? Suppose you're given a square, a unit square. A unit square has 1, 1, 1 on all the sides. And suppose you are told to draw a diagonal that divides the unit square into two right triangles. So that is a right triangle, it's a right triangle, but you don't know the length of the diagonal. So let's call this X. That's a unit square. So you drew a diagonal. So right now, I want to draw one of the congruent triangles. And by the way, it is an isosceles right triangle, 1, 1. It could be 2, 2. It can be a 5, 5. Okay. All right. So I want to find X. By Pythagorean theorem again, we can find X. the hypotenuse is equal to the sum of the squares on the legs, right? Okay, so the hypotenuse squared is equal to 1 squared is 1 plus 1. Therefore, x is equal to square root of 2. I don't want to put plus or minus here. I already emphasized that length is not allowed to be negative. Therefore, the length of the hypotenuse is square root of 2. So 45, 45, 90 special right triangle. I'm talking about degrees. 45, 45, 90 special right triangle. Okay, so let me just bring that triangle here. Crooked. This is 1, this is 1, this is square root of 2. 45, 45, which is isosceles. So it's an isosceles right triangle. So let's go ahead and find the 6 trig ratios. Sine of 45, whichever one you decide to talk about, by Sukatua, it is opposite over hypotenuse. Opposite to 45 over hypotenuse, 1 over root 2, but you are not allowed to write it this way. So you rewrite it root 2 over 2. Okay, now cosine of 45 degrees adjacent over hypotenuse. It is 1 over root 2. So these are, so sine 45, cosine 45, you need to remember that. The ratios for sine and cosine are equal. Also, the ratios for cosecant and secant are equal. All right, so this is same root 2 over 2. And then tangent of 45 degrees is opposite of hypotenuse, opposite of adjacent, and that is 1. So tangent of 45 degrees is 1. Likewise, the cotangent of 45 degrees is 1 too. Okay, so 1. And if you know the sine, cosine, and tangent, you already know the other ones. Therefore, you can answer the questions. So now let's answer the questions in that diagram. So let's answer the question in that diagram. I'm going to grab this and move it. Okay, so in that diagram, we have a triangle that is 6, 6. That is, it's supposed to be negative, negative 6, but I don't want to use negative because it's a triangle, 6, 6. And then we can find the hypotenuse of this triangle. Well, guess what? It's going to be the same thing as because this leg, the legs are equal. So it's a 45, 45, 90. 45, 45, 90. So if this is 6, if this is 6, then I can say this is 6 root 2. I hope you understand. When it was 1, it is 1, 1 root 2. Now that is 6, is 6, 6 root 2. So you don't waste your time solving what is obvious, okay? So 6, 6, 6 root 2, 5, 5, 5 root 2 is an isosceles right triangle. 10, 10, 10 root 2, 20, 20, 20 root 2, x, x, x root 2. So you just make sure, because the reason people don't finish their test is they don't know the quickest method to use. Okay. And okay, now that I have all the sides of this, I can find the 6 trig ratios. They told me to find it. So finding the 6, we find sine of 45 degrees, opposite of adjacent. No matter what happens, when you finish, you have 1 over root 2. Sine 45 degrees is 6 over 6 root 2. Because if you get it this way, you know you're right. See? Even though it's 6, it's 1 over root 2. And when you find the cosecant, it's going to be root 2. Cosine of 45 degrees is 6 over 6 root 2. 6 over 6 root 2 again, because sine 45 degrees and cosine of 45 degrees are congruent. They are equal. They are equal. All right, 2. And this is 1 over root 2 also. Remember, rationalize the denominator. Tangent of 45 degrees is 1. Tangent of 45 degrees is 1, 6 over 6. Okay, since you know the major trig ratios, now you can find their reciprocals, which is easy to find. So we did this the other day, but I just want to make sure that the things that will make it's not nothing is going to break you here unless you did not study. Nothing. None of the questions is going to break you. Trust me, if you study. Okay. Well, we have been doing this since middle school, high school, geometry. If you're given all sides of a right triangle, you can be told to find. We have been talking about SOHCAHTOA, the same SOHCAHTOA. But somebody can always check and see if you know it anywhere. They can change. They can use a table. They can use a table. They can do any kind of thing. Well, guess what? This is what we have been doing since last week. This is the same we have been doing. So it doesn't really matter if somebody decides to scramble what I know and make it look difficult. I still know it. Okay, so you're given a right triangle and they want you to find sine A. Sine A is opposite of perhaps YouTube, search Khan Academy. There are so many